Hello and good morning. We will try to shorten somewhat our presentation. We can't show you the videos we brought along with you, so this will be made shorter. We'll be discussing a European project, which is called Share It, and this is a 3-year-long project. The idea is to try and build a technology which will allow elderly people with physical or cognitive problem to stay longer in their preferred abode, in preventing institutionalization of these patients. The idea is to generate technology which is called care technology with a mixture of other traditional technologies like robotics or AI or communications, with a set of medical indications which are associated to the pathologies that users have. This integration with agents technology generates support for these people in this environment. This European project has 8 partners, and we coordinated at the Polytechnic University of Catalonia. This is the logo of our project. Originally, it was only for wheelchairs, but now we'll see which way things are going. So we'll be talking about robotic platforms. This robot you see here is Roland 3. It's an all-terrain robot to drive people with mobility problems, physical mobility problems. And it has 3 or 4 ways to interact. The normal joystick, a vocal interface, speech-based, and on the chair you see a white object. This is a beret with a joystick, which allows some people to use a joystick associated with the head. And what you see below is a laser beam which permits navigation with obstacle avoidance technology. This has been developed in Bremen. This is spheric. Professor Martinez will be covering this later. This is an ergonomic chair which permits movements. And this is Carmen, a traditional wheelchair which has an obstacle avoidance system. In the base there is a small box with a black line. This is yet another laser, and the basic idea is for the person who drives the chair with a joystick shares management with a machine. The machine contains a space map and has a number of priorities, and if the person makes a mistake and has the intention of going to a certain place and makes a mistake, then that is corrected. Finally, the walker, this one here, and we will have a small demo. So, the robotic platforms have been fully developed, but a robot with a person on it, if that person is cognitively healthy, you can navigate with it as with an automobile. The problem is when you have a user who has a cognitive problem. Therefore, we have to supplement the services. And these are the ones we describe. We have a security assistant avoiding the person to have harm, to hurt themselves. There is a driving assistant generating plans of where I want to go. And if I make a mistake, you'll help me if I have to brake or accelerate. There's a route assistant. How do I know where to go? On my way, I can modify the route. There's a driving assistant which is the in addition to the joystick or the speech recognition system, there is multi-goal navigation, because for complex routes, first to one place, then to another, and then yet to another. But in the middle of the way, I'd like to change over and change the order of my preferences, and this needs to be given told to the computer. And finally, the shared control, which I mentioned before. So there's partly this is partly controlled by the user and partly by the machine. The user drives, but if there's a danger situation and the person can hurt themselves, the control is then removed from the human user and it is taken over by the machine. Other services are the cognitive ones, based on an agenda. The elderly have a rather fixed schedule, and in the schedule you see a number of reminders. Soon you'll have to do something, and let me remind you of it. Then there's the follow-up of daily activities for the elderly. One of the most important tasks is whether they can do a number of activities which are well established. And if that is so, then they are autonomous. Autonomy is lost as the ability to do them is weakened. So we need to offer them services, and that means for us to give the just amount of aid that a person needs depending on their needs and conditions. But we need to follow them up very closely and understand what these people are doing. Then there are help requests. If I have a problem, I must be able to send help. But since I know where I am and which activity I'm doing, I can send information to the person who needs to help me. Finally, there are tutorials. The elderly sometimes forget very simple things, like tying up their shoes or cooking. So the system proposes a number of tutorials which are adjusted to each individual, which are custom-made, so to speak, tailored to the needs of each individual. To make this viable in a non-experimentation environment, in one of the Rome hospitals, one of the partners, an architect has designed this house, which has been physically done, the Jeveli house. It's 60 meters square, where we've generated the whole technology and we've put all the necessary sensors for someone to live there. And what we do now is the following. For people who are recovering in hospital from some sort of incident, we ask them whether they wish to be volunteers, and we test out the technology inside this friendly house. These are the maps with all the sensors. Well, we don't have it now. And this is the intelligent part of the system. It is an intelligent system, which is, in fact, a set of applications associated to different computational elements. In pink, you have the agent associated to the user, the patient user. In yellow, the environment agent, receiving all the information of the environment and controlling the environment itself. A third element is an agent associated to the caregiver, the person helping the patient, and also we have a central agent who monitors all the people who are receiving these services. Now, these agents have a number of things they now have to do, a number of goals they have to fulfill, and a set of pre-established plans that they must carry out. When interacting with a person in a truly dynamic environment, things change. So the system must be able to replan everything and to learn from the interaction. We have 3 of these agents. I will not go into the detail. And now let's look at the user profile. we have two big profiles. One, people with a physical problem, and another big group, people with cognitive problems. In general, in the elderly, we do not find people with only physical or only cognitive problems. In general, there is a comorbidity problem. Therefore, there's a mixed profile. In general, we work with a type of population which has suffered a stroke or incipient Alzheimer or dementia, or with Huntington's chorea in a more advanced stage. But anyway, this technology can be extended to many more users. It's a very adaptable technology. And then there's also a classification of these profiles between mild, moderate, and severe. And for the time being, we are working on the mild cases. And why? Because we know that these diseases are degenerative, they will increase with age, and therefore we wish to find people in their mild point of their diseases, so that when they reach the mid or the moderate situation, they will need more services, but then later on they'll be in a severe condition. This is when they will have to be institutionalized, and our system will not be useful at all for them. This is why we concentrate on the mild category. And these are some of the things we found in the way. Partial palsy, for instance, or aphasia, or apraxia, agnosia, dementia. And all of these things are sometimes mixed in the individuals who are going to be given a vehicle to operate. So you need to think that the agent, the patient, needs to give support to somebody who at some point may lose contact with reality because they entered another stage of their disease. And neglect is a problem. People with neglect, they lose half the world. What you see with the right eye cannot be seen any longer. And you need to find a way to complete it. So when they see